In this episode, a professor who gets his students out into the world so they can see firsthand how their skills in chemistry and chemical engineering can help communities solve their sustainability challenges. I'm joined by Dr. Glenn Hurst, a professor who specializes in green chemistry education at the University of York. Welcome, Glenn. Thank you very much for joining us.
Pleasure to be here. Thanks so much for the invitation, James.
So, could you please tell us about this approach you have for helping your students to understand how to use chemistry and chemical engineering to help folks out there in the world?
So much of my work is working with students as partners to excite and engage them about green chemistry, but while also taking it a step further, once they know about green chemistry, to be able to make a real difference in the world. And there's been some fantastic opportunities that our students have led on. It hasn't been me, it's been them leading, that they've made material differences, yes, in the UK, but in other parts of the world too, to spread the green chemistry message, but actually to improve the lives of people from both more and less economically developed countries. And it's just such a privilege to be able to work with such great ambassadors for green chemistry.
Terrific. Glenn, could you please give our listeners a sort of a broad view of the outline of what one of these projects might look like?
Yes, of course. So all of these projects really seek to address a big global problem. And really, we seek to look at the United Nations Sustainable Development Goals as a little bit of a prompt in terms of what that might be. Typically, this really affect various different communities. Now, this might be in industry. Perhaps some of our industrial partners that we work with have a particular challenge, and the work that we are doing at York through research and with our students, the students can actually lead in trying to solve that challenge. It might be working with communities in less economically developed countries, such as Brazil or Peru, for example, where really basic amenities and access to them might be a really significant problem, whereby we can come in, given that problem, take a green approach to try to solve it while teaching and spreading the green chemistry message, actually coming up with something deliverable for these communities to improve their quality of life.
That's fantastic. And Glenn, you sort of just gave us a wonderful little preview of my next question, which is the benefits that, broadly speaking, that arise out of these projects. You just hinted at them, but I'd love to enumerate them more clearly for the audience. There were sort of three benefits that we had talked about previously. I'd love if you could put those on the table for us, please.
So the benefits of the projects that our students engage with is threefold. Certainly for them to be able to learn green chemistry and get involved in such applied projects that can have a really meaningful impact is, as I understand it, so fulfilling for them and helpful from an employability perspective. Also, by engaging in green chemistry education projects with others, it gives others the opportunity to engage in green chemistry, to practice green chemistry, to become change makers themselves. And because the projects themselves are all geared around key and important problems that are facing those communities, it actually seeks and often does create a solution to those problems. So it's a win win win.
Terrific. Well, thank you for enumerating those for us, folks. If you stay tuned, we are going to get to some wonderful, and wonderfully specific examples of what this work looks like in action. But before we get there, Glenn, I want to take a step back again and kind of, from your words, sort of why green chemistry? Why do this? And I think I'd start with. Um, you had mentioned when we talked previously that there came a point in time you weren't exposed to green chemistry as a student, but you were when you joined York University. And what is it specifically about green chemistry, in your own words, that hooked you?
That's a great question, James. I mean, as you mentioned, as part of my education within higher education to PhD, I didn't know what green chemistry was. I happened to be doing research that necessitated the need to think about green chemistry principles purely because of the application. But I didn't know about that. And then I came to the University of York to work with the Green Chemistry Centre of Excellence. And I realized actually what I've been researching on for 3 or 4 years, it actually was green chemistry all along. And had I have learned green chemistry before then, probably would have been able to do better research actually and being able to come up with more meaningful outcomes. And so since then, from learning really from colleagues at the University of York and pioneers around the world, it's made me, I think, a better chemist. It's inspired me to want to pass that on to the next generation, such that they can be engaging in green chemistry as soon as possible. And you know that doesn't necessarily have to be doing chemistry. It can be things around the home. It can be living a more sustainable life. And there are just so many benefits towards doing that. And through taking a green approach, yes, my chemistry, I think, has improved, has become more meaningful and to help others. But actually in other parts of my life, I think things have got better. I think I've been able to live more sustainably, bearing in mind social, economic, and environmental implications. So it really has transformed the way I approach my career, but also life in general, I guess.
You've mentioned the word meaningful a few times, and I think in reference to yourself and to your students in terms of what this work means to you. What's that all about? What about green chemistry do you think is meaningful to you, and do you think is meaningful to your students?
Thanks for that. Yeah, I think from my perspective, it's the transformative approach that it actually has and the impact on people's lives that for me, no area of chemistry does. But then at the same time, the more I learn, the more I feel, well, isn't this just how chemistry should be done? It shouldn't necessarily be an actual separate discipline of green chemistry, but it should just be how we go about doing things at all levels. And for me, given the projects that my students have been engaging with, it's that transformative impact on them, on the people that they then go on to educate, and the communities themselves, in that their lives are better. And I wouldn't have had any of that without green chemistry.
Wonderful. Well, thank you. All right, now let's step back into the work you're doing, and we hinted at some of the specific projects that you're doing with these in these different communities around the world. I think I'd like to start with Peru, if that's all right. You mentioned a project with Peru. If that's an okay one for you to start with, if so, could you tell us about that project, please?
Absolutely. Yes. So this really was about solving a problem. There are communities in Peru that we are connected with that don't have access to clean drinking water or water for sanitation. Really, really significant sustainability issues. And we want to try and do something about it. We wanted to try to help. We wanted our students to take the lead in helping using a green chemistry approach. And so, what they ended up learning from Peru is that certainly our friends in the mountainous regions, there's lots of fog. But unfortunately, the access to water is restricted. And so, what our students came up with while embracing green chemistry in conjunction with chemical engineering, what they did was they were able to design fog catchers, if you like. And the idea was that fog would be caught in nets via a mesh type structure. And through condensation, that fog would condense into water that could subsequently be used for exactly what was lacking in these communities. And so, this piece of work was our students in York working directly with these communities, understanding what the problem is, and taking a green approach to optimize the design of these fog catchers such that as much fog could be caught and water could be collected to be subsequently used. And of course, from our perspective, this is great from an education perspective. It's teaching students the circular economy, green chemistry through an engineering lens. It's doing that also with communities in Peru who can go on to design these fog catchers themselves at a larger scale and pop them in different places. And it's also solving that big problem. So we are just so privileged to have been able to get involved in this really.
It's so interesting on many levels, but I think not the least of which is a wonderful principle that others in your field, the field of green chemistry, have talked about, which is this work, these ideas can be put into practice. You don't need the world's fanciest laboratory to do this work, to put the principles of green chemistry and green engineering into practice. Certainly, there are occasions and there is work that require the newest equipment, the fanciest lab available. But this work you're demonstrating, I don't want to say simple because it's not simple and it's so important. I guess maybe elegant. It's elegant in its simplicity in terms of am I making sense? The materials you're working with, the where you're doing this, but still very much tapping into the core ideas and creating experiments and solutions in green chemistry and green engineering. Am I making sense at all? And if so, could you help me here?
That's absolutely right. For us, it's all about transferability and
Mhm.
making transferable interventions that can teach green chemistry, can solve a problem in different places. And yes, of course, depending on what it is, some are more bespoke than others. But so that's a component to it to get everyone, and I mean everyone, on board with green chemistry in terms of its simplicity, but also from an educational perspective so that it can engage people, engage chemists to be able to alter their practice for public good, for many reasons, really, but also to engage people that aren't chemists, that aren't particularly interested in green chemistry, or maybe they don't know about green chemistry. And through these types of activities, they can say, wow, I want to be a part of that.
That's wonderful. Let's move now, if it's okay, there's another wonderful example because I want to give folks a feel for what these different things might look like. And the example I was going to prompt you with this time was the other one we discussed, which is in Brazil. And again, if that's okay, if would you could you please tell us about the project in Brazil?
Absolutely. We've had a long-standing relationship with friends in Brazil wanting to adopt a green chemistry approach. And a couple of years ago now, I went over there, um, various places in Brazil to understand the educational system, understand some of the challenges really that the country was facing. Yes, from an educational perspective, but from a scientific and sustainability perspective too. And so that was that gathering information stage. And we really brought it back home and thought, right, how can we work with our friends to really try and solve some problems and make things better here in multiple guises? And how can we involve our students while doing that? So one of the problems that we came across was relating to unavoidable food waste. And so within Brazil, they are one of the largest exporters of oranges. And of course, when you and I eat an orange and enjoy an orange, the first thing we do is peel it. But unfortunately, what very typically happens is that peel ends up in the trash. But actually, we can get a lot of value from that peel. We can valorize it. We can move away from that being thought of as a waste stream to a resource and to be able to make a real product with it. And that's what our students embarked on. So they were able to initially work between themselves in York but then implement this in Brazil such that they could extract valuable chemicals from this orange peel to make, in this case, marmalades. And so they were copying off Paddington Bear and were able to make a usable product that we could implement within communities, including favelas within Brazil, so that they can get value from waste, a waste resource that was really rather ubiquitous in the areas, including the very poor areas that we visited. And in doing so, can learn something, can learn about green chemistry. Students at a higher level ended up developing an experiment for undergraduates where they could investigate the flow properties of marmalades, for example. And so, and they've actually been able to publish this work, and other universities internationally have actually adopted it within their universities too. So it's able to have that impact at different levels, which is quite nice. But what we wanted to do here, we wanted to go one step further. And in the next related project, we wanted to involve the Brazilian students more directly in solving the problem. Not just our students in the UK, but working closely with chemistry students in the countries where we want to solve the problem. And this was Brazil once more. This was waste valorization once more. This was looking at sour milk, milk that had gone off effectively, and trying to make that into something useful again. And it was this collaboration between students in the UK and overseas was crucial to making this work. This was all about effectively taking the sour milk and through a benign, safe, quick process, turning it into bioplastics. Okay? And naturally, that's a nice teaching point if you think about all the issues with petroleum derived plastics in our society, in our oceans, etc. The interesting additional point here is that via a very similar process, you can make cheeses, paneer cheese, which is again another usable product, but allows us from a teaching perspective to teach about the ethics of doing green chemistry and for students to decide for themselves what sort of chemistry they should do and what products they should be creating in ethical circumstances. Is it right, for example, that we're making a bioplastic, maybe for decorative purposes, for usability via a certain process, when our friends in India depend on that process for nourishment? So it's been quite a nice journey so far in terms of engaging multiple stakeholders, mostly students, in green chemistry to make products from waste.
Glenn, it's really interesting you mentioned the ethics piece of this and how green chemistry sort of fits within a larger, a bigger decision process. And I want to come back to that. But before we get there, I want to back up a little bit and make sure people heard and understood some of the potential that was in what you just spoke about. Because you talked about the sour milk and the oranges, both taking this food waste and making value out of it, but in two ways. One was perhaps yielding actually another food product, and the sour milk leading to cheese, the orange peels leading to a marmalade.
Mm.
But also this idea that both of these food waste streams could be the source of important chemicals for making and processing other things that we use in the world. Is that fair to say?
And that's absolutely the case. Yes, there are so many different products that beyond foodstuffs that we're actually able to get from food waste. A really nice example is the recent commercialization of something called Cyrene that we've done. That's from food waste, and it's been developed into a solvent that we've used for mixing chemicals effectively, a much greener solvent that industry has and is slowly adopting for various pharmaceutical manufacturing processes, for example. And we actually sell this solvent across the world, and it's marketed by really key players. So that's just one example there. There is a portfolio of products that affect our everyday lives that we can valorize and produce from waste. Absolutely.
And just I think you hinted at it enough earlier, but so folks get it. To valorize something means, right? Am I taking something that that at present doesn't have value and getting value from it? Is that right?
Absolutely right.
Okay,
Yes.
great. And I love that with these chemicals you're talking about, extracting them from orange peels or sour milk or whatever other food waste you're talking about. Um, Again, just to put a fine point on it for folks, it's I think if I heard you right in that example, you're yielding a new solvent in that one case you mentioned
Mm.
that is a safer to use solvent for an important process. So that's it's a safer outcome, but you're
Yes.
also now getting that solvent from again a renewable a waste stream
Yes.
in terms of a sort of a circularity concept
Hmm.
from food waste rather than say petroleum as the source for this solvent, right? Is that fair?
It's an exact
Yeah.
replacement, as you say. I mean,
Yeah.
one other related example is every morning I have coffee, and there's spent coffee grounds waste from that, and we've recently, through working with our students, managed to make biodiesel from that spent coffee grounds as a replacement for diesel, leaded petrol full of petroleum, for example. So yes, there are many, many opportunities and really exciting things that we can do with food waste to have a really impactful effect on our society. And that's why taking a green approach and learning about taking a green approach is just so important at the moment.
And what's now is when I want to come back to what you raised with the in the sour milk example, um, where again you saw an opportunity in Brazil, I think, right, to convert the sour milk into polymer into these types of chemicals.
Yes.
Um, but also recognizing that sour milk can become a food source. And so there's a there's a decision to be made that chemistry can't answer, which is what's the as you I think you said the ethical decision of where we have a source here that can go in two different ways, and there's some thought that has to happen as
Mm,
to what's appropriate in the larger context. And it's that larger context that I'd like to ask you about because I think you've talked about it in terms of sort of systems thinking, holistic thinking.
mm.
Could you, if that's enough of a prompt for you, could you your concepts that you're working with your students on for having them learn green chemistry in the context of bigger ideas of larger a larger whole that needs to be considered as they practice these skills. Does that make sense?
Totally.
Okay.
Yes. For me, green chemistry is all about that holistic thinking effectively. And, moving away from thinking in silos, kind of a reductionist approach. Um, if you take a particular process, for example, and do one adaptation to do it at a lower temperature, for example, there might still be many, many, many problems associated with it. It might still be derived from petroleum-based feedstocks, for example. There might still be a lot of waste, a lot of byproducts that aren't used. It might still be very toxic. And so, really, yes, we have to train chemists to certainly think in a more holistic way and to try, and there is compromise involved, as you've mentioned, to try to move towards a greener system from a chemistry perspective. But as you've mentioned, it goes beyond that. It goes beyond the environmental component to sustainability to think about the societal and, of course, economic as well. Just because we can do this, should we do it? What are the impacts of doing it on all of the key players and stakeholders and actors? And we need to understand that carefully. And so, from an educational perspective, what we are trying to do with our students, with other students within chemistry, yes, to be able to practice the chemistry, but to be able to think of the understanding the system they're looking at and how it interacts with other systems as well, and how making one change affects other things. And even if some things do get better, should we do it? What are the priorities and what are the effects? And
Wonderful. Oh, sorry, forgive me.
it it is very difficult to get right, and sometimes there isn't a perfect answer. It depends on what our goals are. But we want to be as advantageous as possible, and we need to recognize those challenges and come to the best possible decision through doing so.
Yeah. What's interesting, I think, is that it's in placing the technical skill of chemistry in this larger context of thinking, I think is at the core of it all in terms of solving problems. Chemistry has been capable of some, magic for many, many years now, but this larger thinking that was lacking is kind of what led to some problems. Developing a paint that looks wonderfully shiny on the wall, but oops, it has lead.
Yeah,
Because at the time, people just they were it was all about performance and cost, and
yeah,
not this larger thinking of is it healthy for us.
yeah,
Um, Let alone the wider things that you're hinting at, which is sort of the echoes upstream and downstream for the users, for all the part players. And as you said, it is a complex challenge, but we're at a point where we need to tackle those complex challenges. So thank you for doing so. All right, I would like to now take you to in terms of folks out there in the world learning these things that you're working on. You have participated in a green chemistry, green engineering education piece for the United Nations.
mhm.
Sort of, I think, as a way to sort of more broadly distribute these kind of thoughts and skills and ideas. Could you just briefly tell us what this piece is, and yeah, just what's this all about?
Of course. Yes, so the remit behind this was linked to exactly what you mentioned, to move us away from the unsustainable trajectory we've been on, and really perturb the system and move us towards a more sustainable and circular future. And there's going to have to be change, very significant change. And education is the key towards doing that at all levels. And so, really, this work with the United Nations through the Environment Programme has sought to complete a global manual effectively on how to teach green chemistry in a transferable way in all levels. So, from kindergarten, primary school education, through university, up until continuing professional development, so that, for example, employees in companies are empowered to be able to make change within their company such that it's more sustainable, and in a multitude of environments. Because really, it's really through education that we can equip the next and current generation to make these green changes that are so desperately needed when they go on to become scientists, engineers, and policymakers. And so, in the coming month or so, the United Nations Environment Programme are going to publish this framework manual that will be available open access for all to access through the UNEP website. And effectively, many of the interventions that our students in York have done, either in isolation or with other students and colleagues internationally, they'll be used as indicative examples for others to be able to spread the green chemistry message and to be able to teach others, so that we may, hopefully as a collective, be able to perturb the system and move us towards a more sustainable future. Yeah.
Fantastic. Now, is that am I hearing you right that the for the examples that we've just discussed about Peru and Brazil and other work that you all in your program have done that we haven't discussed, those are many of those are going to be wrapped up in this manual for the United Nations as case studies, as it were, for others to read more about and learn from. Am I hearing that correctly?
Absolutely that,
Okay.
yes. And indeed, these activities have also been published in open access journals as well. And so, if as a member of a public, you wish to access these, yes, they're available via the United Nations program, but also you can see the original work open access to all for you to give it a try as well.
Fantastic. Now, just logistically, for folks, because you said ready in about a month. So whenever folks might be watching this interview, that is roughly speaking, effectively that by, let's say, is it January 2024,
Yes,
these materials will be available. Is that right?
absolutely
Yeah.
that.
Yeah.
Yes, yes.
And available through the UNEP, United Nations Environment Program
Hmm.
website. And am I right to guess that they will also be available at some point through the green chemistry teaching and learning community?
Yeah, that's
Okay.
absolutely right. So, as
Okay.
well as being published in the actual journals, the Green Chemistry Teaching and Learning Community, pioneered by Beyond Benign in conjunction with various partners, will be signposting and hosting all of these activities. So, do sign up and learn what you can from our students, but from all the educators as part of this community platform to make a change and to make an actionable change. As we discussed earlier, you don't have to have a fancy lab to be able to practice green chemistry. It's accessible to all, and I'm sure there'll be something on that platform for you.
Yeah. And for the viewers, there's a whole nother episode specifically about the green chemistry teaching and learning community as a wonderful resource for folks to go to. The website, just to quickly state it here, is gctlc.org. Um, Glenn, you were an active participant in bringing this to life and developing it, correct?
That's right. Yes. No, I've been
Yeah.
very, very privileged
Wonderful.
to really
Yeah.
work as part of a coordinated international effort, and it's such a good resource. So do tune in for that episode.
Yeah, check out that episode, folks, and we'll have a link to that in associated with this video as well. All right, Glenn, we should probably head towards wrapping up this discussion. I'd love to talk to you for many hours to come, but we should probably wrap up. And I'd kind of just like to wrap up with this question. Um, as you think about this work that you do with your students,
Mm.
um, and you can think about this in terms of work you've already done, or as you sort of look towards the future and work that's coming with your students in working with these communities and developing these projects to teach all involved and yield real world solutions. Um, just what gets you most excited as you think about this stuff?
It's a great question, James. I think it comes down to those 3 points really, in terms of what we're trying to achieve. Certainly, educating and doing that in an innovative and fun way to engage students, not necessarily within green chemistry, but just chemistry more broadly, has always been on my agenda. I get a lot of satisfaction from that. Now I've learned about green chemistry. I mean, that's really the final part of the puzzle for me, and I get so much personal fulfillment from actually doing that. I think it's so great that the students, they do too. I think, and they can have an impact. And actually, yes, they're teaching green chemistry, but they're doing something new as well. And maybe that might be research. Maybe it might be something actionable, like the ideas we talked about. At the moment, they're actually looking at thinking of getting value from disposable face masks and how we can actually transform that into a usable product. So I think for me, it's incredibly exciting thinking about new ways to pass on green chemistry, thinking about solving problems, but ultimately moving us towards a place where green chemistry is just chemistry.
Terrific. Well, thank you very much for joining us and for helping us understand all this terrific work you do. I really, really appreciate it. And best wishes for this work going forward.
Thanks, James. It's been a pleasure.